Hello everybody. In this video I will be talking about the benzocaine lab which we will be doing this week. First, for some safety considerations. This week we will be working with sulfuric acid, which is corrosive and can cause skin burns. If you spill some sulfuric acid, it first needs to be neutralized with a base like sodium bicarbonate. Then clean the neutralized spill with water and paper towels. If you spill some sulfuric acid on your skin, make sure to thoroughly wash the skin with water. Always wear gloves and goggles when in the laboratory. And dispose of liquid waste in the liquid waste jugs and solid waste in the pail. This week we will be synthesizing benzocaine. Benzocaine is a local anesthetic or a painkiller. Benzocaine is the active ingredient in oral anesthetics such as Oragel, and it is also the active ingredient in some throat lozenges. In this lab, we will be synthesizing benzocaine by a Fischer esterification reaction. Shown is a general Fischer esterification reaction in which a carboxylic acid reacts with an alcohol in the presence of an acid catalyst to produce an ester and water. This reaction is in equilibrium, and remembering the Chatelier's principle, to push this reaction in the forward direction, one can either add a large excess of one of the reagents or continuously remove some of the product from the reaction. For example, one could continuously remove water from this reaction by distillation. For the synthesis of benzocaine, we will be taking 4-aminobenzoic acid and ethanol, which react in the presence of a sulfuric acid catalyst to yield ethyl 4-aminobenzoate, also known as benzocaine, and water. And for our reaction, we will be adding a large excess of ethanol to push the reaction in the forward direction. Now for the Fischer esterification reaction mechanism. The first step is that the carbonyl oxygen of the carboxylic acid will become protonated by removing a proton from a protonated solvent molecule. This makes the carbonyl carbon more electrophilic and more prone to nucleophilic attack by an alcohol molecule. Then the electrons from the double bond will move up to the oxygen atom. And the third and fourth step are a proton transfer, in which an alcohol molecule can remove this proton, leaving these electrons behind on the oxygen. Then the hydroxyl oxygen can remove that proton, leaving these electrons behind on the oxygen. Now, essentially what we've done is moved a proton from this oxygen to this oxygen right here. Now what can happen is that these electrons can move here to form a double bond, which causes water to leave, which is due to the positive charge on the oxygen atom. And the final step is a deprotonation step, where an alcohol molecule can remove this proton, leaving these electrons behind on that oxygen, giving us our ester product. Now for a summarized procedure of the lab. First, add 1.2 grams of p-aminobenzoic acid and 12 milliliters of absolute ethanol to a 100 milliliter round bottom flask. Next, add 1 milliliter of concentrated sulfuric acid dropwise to the round bottom flask. Heat the mixture under reflux for 60 to 75 minutes. Allow the reaction to cool for a few minutes, then transfer the reaction mixture to a beaker which contains 30 milliliters of water. Neutralize the mixture with aqueous saturated sodium carbonate. This will cause benzocaine to precipitate from the mixture. Separate the benzocaine from the liquid mixture by vacuum filtration. Next, dry and weigh the crude product. Calculate the percent yield and determine the melting point of the crude product. Then recrystallize the crude product by the mixed solvent method with methanol and water. Then dry and weigh the pure benzocaine and calculate the percent yield and determine the melting point of the pure benzocaine.